How CPUs are designed and built. Fundamentals of computer architecture. We all think of the CPU as the brains of a computer, but what does that actually mean? What is going on inside with the billions of transistors to make your computer work? In this 4-part mini-series we'll be focusing on computer hardware design, covering the ins and outs of what makes a computer work. The series will cover computer architecture, processor circuit design, VLSI, very large-scale integration, chip fabrication, and future trends in computing. If you've always been interested in the details of how processors work on the inside, stick around because this is what you want to know to get started. Part 1. Computer Architecture Fundamentals. Instruction set architectures, caching, pipelines, hyperthreading. Part 2. CPU design process. Schematics, transistors, logic gates, clocking. Part 3. Laying out and physically building the chip. VLSI and silicon fabrication. Part 4. Current trends and future hot topics in computer architecture. Sea of accelerators, 3D integration, FPGAs, near-memory computing. We'll start at a very high level of what a processor does and how the building blocks come together in a functioning design. This includes processor cores, the memory hierarchy, branch prediction, and more. First, we need a basic definition of what a CPU does. The simplest explanation is that a CPU follows a set of instructions to perform some operation on a set of inputs. For example, this could be reading a value from memory, then adding it to another value, and finally storing the result back to memory in a different location. It could also be something more complex like dividing two numbers if the result of the previous calculation was greater than 0. When you want to run a program like an operating system or a game, the program itself is a series of instructions for the CPU to execute. These instructions are loaded from memory and on a simple processor, they are executed one by one until the program is finished. While software developers write their programs in high-level languages like C++ or Python, for example, the processor can't understand that. It only understands ones and zeros, so we need a way to represent code in this format. Programs are compiled into a set of low-level instructions called assembly language as part of an instruction set architecture, ISA. This is the set of instructions that the CPU is built to understand and execute. Some of the most common ISAs are x86, MIPS, ARM, RISC-V, and PowerPC. Just like the syntax for writing a function in C++ is different from a function that does the same thing in Python, each ISA has a different syntax. These ISAs can be broken up into two main categories, fixed length and variable length. The RISC-V ISA uses fixed length instructions. For more on this story, visit the news article link.